Alright, now we're live. I'm going to try to go over some of these. I don't know if I have a ton of time, but we'll do our best. So we did the odds. So we'll start with that first one. So you can grab the PDF and follow along. But anyway, as a positively charged rod is brought near but not allowed to touch the knob of an electroscope. So here's my electroscope. There's the knob. And you have a positively charged rod. Brought near, not allowed to touch. All right, the leaves will diverge because, so what happens here, we got two leaves and they move far apart. And you got to think about where the electrons are going. So the electrons will go up. So if we have electrons going up, that means we have a surplus of positive at the bottom. So negative charges are transferred from the electroscope to the rod. Nope, they're not touching, so they don't get transferred. Negative charges are attracted to the knob. That is the correct answer. And positive charges, we can cross these out because positive doesn't move. So those two are out of the way. Question 3. When an object is brought near the knob of a positively charged when an object is brought near the knob of a positively charged electroscope, the leaves on the electroscope initially diverge. All right. So we have another electroscope, but this one's already positive. So we have our electroscope here. It's already positive, so the leaves are separated. It's also positive up here. The leaves will, when objects are brought near the knob, oh, they diverge. I'm sorry. I was assuming it was a neutral object coming near it, but the leaves will initially diverge. So that means they get further away. Sorry, I misread the question. So the leaves get further away, which means this has to become more positive. So what would make that more positive down there? If more negatives went to the top. And what would bring more negatives to the top? It would have to be a positive. So the charge of the object must be positive. I'm sorry, I got confused and paused there because I assumed it was a neutral object. I'm like, why would they diverge? But anyway, if they diverge, that means they get further apart. They get further apart because they're more positive, which means more negative up here. Because the only way to gain a positive at the bottom is to lose your electrons, so they go up here. And the only reason electrons will go up here is because that was positive attracting them. Question 5. If a positively charged rod is brought near the knob of a positively charged electroscope, the leaves will, this is the same thing. They will diverge. Does it touch? No, it's brought near. So if a positively charged rod is brought near the knob of a positively charged electroscope, the leaves will diverge. That's the same thing as question 3, actually. Question 7. Negatively charged rod A is used to charge rod B by induction. Okay. So induction, we know, no contact, and it flips the sign. So A, B, C. So A, which is negative, is brought near B and charges it, which uses induction, so it flips the sign. Object C is then charged in direct contact with B. So C has contact, which is conduction, so it has the same sign. So the charge of C is positive. Like that question. Question 9. Which diagram below best illustrates a neutral electroscope being charged by conduction? Conduction needs contact, so these two are out. And when you charge by conduction, you have the same sign. So this is positive and the electroscope is positive. So it's choice 4 because they're both positive and there's contact. Question 11. An object is charged positively when rubbed with a piece of silk. The object became charged by, well, how do you become positive? Well, you can't gain protons, which must be you're losing electrons. So it's choice 1. Neutrons and positrons should have been crossed off. Flip it. Question 13. When a rubber rod is rubbed with fur, the rod becomes negatively charged. How do you get negative? Well, you're gaining electrons. So rubber rod is rubbed with fur. The rod becomes negative. So transfer of, I need electrons to the rod. Where is that? That's choice 3. The rod's negative, which means it's gained electrons. Let's see. Which magnitude of charge could not be found on an object? Uh-oh, I may not finish this video. So the smallest charge you can have is called an elementary charge. That's on your reference table. It's 1.6. So this would be 1. Now if we have 2 of those, it becomes 3.2. That's the second smallest amount of charge we can have. If we have 3 of them, it's 4.8 times 10 to the negative 19 coulombs, and so on. So the one that we can't have, we can have both positive and negative, because we could have protons or electrons. So the one we can't have is choice 1, because that would be half the charge of a electron, and we can't cut electrons in half to get half a charge of it. 17. A sphere has a negative charge of 6.4 times 10 to the negative 7 coulombs. Approximately how many electrons must be removed to neutralize this? So this, we need our reference table here. What's the number? We have 6.4 times 10 to the negative 7 coulombs. So I need to find a ratio so I get rid of coulombs, and I need elementary charges instead. So I have it here, 1 elementary charge is this, or I could use 1 coulomb is that. So I'm going to use 1 coulomb is equivalent to 6.25 times 10 to the 18th elementary charges. I'm using that one just because it's multiplication instead of division. I like that more. But you could just divide by the other number instead. So I go to my calculator, 6.4 e to the negative 7 times 6.25 e to the 18. And I got 4 times 10 to the 12, which is choice 4. All right. What is the charge of a proton? That's an elementary charge. This one should be easy. So it's choice 3. Question 21. Oh, can we do it without doing the other one? After the spheres A and B are separated, which graph relationship? It's going to be choice 2, because it's you got a 1 over r squared relationship here as they separate. Question 23. How is a positive charge usually given to a neutral object? Electrons are removed. Said that a ton. If the charge on each of 2 point sources is doubled, the electrostatic force is 4 times. And that's because electrostatic force, I don't know how much time I have left. I may not make it to the end. Q1, Q2 over r squared. So if you double this one and double that one, 2 times 2 gives you 4 times the amount of force. Oh no, how long has this been on the screen? Maybe you can't see it. Google's trying to get me to sign in. Let's see, do I have enough time to do the next few? Do we have them? 27, oh, we did 27 in class. The force, so for this one, 27, we did this in class already, but you're using F equals K, Q1, Q2 over R squared. Plug your numbers in and just remember that K equals 8.99 times 10 to the 9th. It's on the reference table. Skip 29, and then 31, rushing. If the charge on one of 2 small charged spheres is doubled while the distance between them remain the same, the electrostatic force. Oh, I like this. Fe equals K Q1 Q2 over R squared. So if the charge on one of 2 small spheres is doubled, I'll double that one, while the distance between them remains the same, so not that R doesn't change. What happens there? The electrostatic force is also doubled. Whatever you do to the right, you got to do to the left. So that's choice 2. All right, so that's that. I was able to finish. In under 10 minutes. So that was your homework. Good luck. Email me if you have any questions.